All right, so our next topic that we're talking about is molarity and dilutions. Molarity is our number of moles of solute dissolved in 1 liter of solution. So that's our official definition. Molarity and concentration are the same thing. So if you ever see concentration, we're talking about molarity. We're talking about the amount of our solutes that dissolved in some volume, typically 1 liter of solution. So that's moles of solute, the thing that's being dissolved, or our lesser quantity, in a liter of solution. And we are going to abbreviate moles over liters as capital M. So anytime you see capital M, we're talking about molarity or concentration. So here we're going to be doing some conversions to try to figure out the molarity of a substance. So example number 5 says, how many milliliters of 12.0 molar hydrochloric acid contain 7.30 grams of hydrogen chloride solute, and we're given the molar mass of hydrogen chloride, that's 36.46 grams in 1 mole. All right, so we're going to be starting again with our single unit, not our derived unit, not the moles per liter. We're going to start with our single unit and start our conversions from there. So we have, we're going to start with our 7.0 grams of hydrogen chloride. Let's talk about our units real quick and our mapping out of units. So we're starting with grams. Using our molar mass, we can get to moles. And then using our molarity, our concentration of our hydrochloric acid, we can get to liters. So we're going to be going grams to moles, moles to liters. So we're starting out with grams, which means that we need to cancel out grams on the bottom and get moles up top. So we are using our molar mass that we're given, so 36.46 grams. And then from moles, we are going to get to liters using our molarity. So that's the 12.0 moles of hydrogen chloride solution in 1 liter. So at that point, we're in liters, but we want to know milliliters. So we need to convert liters to milliliters. That conversion is in 1 milliliter. That metric conversion is 1 milliliter is equal to 10 to the negative third liters, which is also the same as 1,000 milliliters in 1 liter. So either of them works. They'll both give you the same answer. Same thing, just different format. So after we put this in our calculator, we got grams canceling, moles canceling, liters canceling, and we're ending up with milliliters. So we should get, with 3 sig figs, 16.7 milliliters for our hydrochloric acid, and 17.3 grams of our solute. So that's how we're doing these types of calculations. So let's look at example number 6. So what is the concentration when 0.3 moles of sodium chloride is dissolved in water to make 400 milliliters of solution? So concentration is the same thing as molarity. So we're looking for units of moles over liters as our final answer, or for our final units. All right, so we're going to start with our unit, our single unit, but this problem has 2 single units. We need to use both of them, but we're going to hold off on using moles because we're going to use that as our numerator and then divide by our denominator, our volume. But first we need to convert milliliters to liters before we can even divide them. So that conversion I have here. So 400, so this decimal is really important. We got 3 sig figs there. 400 milliliters, we're canceling milliliters on the bottom, and we're using our metric to metric conversion, so that's 1 milliliter is equal to 10 to the negative third liters. And we are going to get 0.400 liters for our volume. At that point, now we can divide moles in liters to get our concentration of with units of moles per liter. So we're going to do our 0.300 moles divided by 0.400 liters, so 3 sig figs for both, and we're going to get 0.750 molar sodium chloride solution. All right, let's look at example number 7. So it says, a solution is prepared from 17.0 grams of sodium chloride dissolved in water to give 150 milliliter solution. What is the molarity of the solution? And we're given the molar mass of sodium chloride. So our molarity, again, we got units of moles over liters. And we're going to abbreviate it as capital M in our final units. Okay, so here we are given a number of grams, and we're given a number of milliliters. Our molarity units are moles over liters. So technically we need to convert both of these numbers. So our first one, I guess we'll start with is grams, because it's written first. We're going to convert grams to moles using our molar mass, sodium chloride. And then we need to convert milliliters to liters. And then at that point we can divide them like we did in example number 6. So let's do that first. So we're starting with 17.0 grams of sodium chloride. We're multiplying by the unit factor with our molar mass. So grams cancel on the bottom. We're left with moles. And we get 0.290 ... We are not rounding until the very end. So do not round until the very end. Leave that number in your calculator. So then we're dividing by liters. So 150 milliliters is the same as 0.15 liters. A trick that you can use for converting liters to milliliters is just moving the decimal place 3. So 150.0 milliliters. I'm taking my decimal place and I'm moving it over 3 to the left. 1, 2, 3. That's going to put me here, and I just need a 0 out in front. So 0.150 liters. Technically need to add another 0 there for 4 sig figs. So that is your cheat right there. There are 3 zeros in 1,000, so we move the decimal place over 3 to get to liters. Alrighty. So after we divide, we get a molarity concentration for our sodium chloride solution, 1.94 molar sodium chloride solution. All right. We're going to be talking about dilutions next. So dilutions, here is our official definition. The process of lowering the concentration of a solution. So we're adding more solvent to a solution. Typically, we're going to be adding water, but not always. Dilutions are super, super important in every part of our lives, really. So if you use acne products, a lot of acne products have salicylic acid. Salicylic acid is an acid, obviously. And you might look at the ingredients in your acne product, and it might say like 1 or 2% salicylic acid. That means that our salicylic acid in your product is diluted by a lot. It is 1 or 2% of what it could be, what it typically is if we found it in its highest concentration. So we don't want 100% salicylic acid on our face, just eating away at our face. So dilutions are super, super important for basically any product that you see. Any kitchen product, cleaning product, just beauty product, we see them everywhere. So we're going to be doing a bunch of calculations with dilutions. right here. So this is our dilution formula that we're going to be looking at. So M1, our initial molarity times our initial volume, is equal to our final molarity times our final volume. You guys have been, so in chapter 11 with our gas laws, this is very similar to our, like the process of solving pressure and volume problems. So P1 V1 equals P2 V2. So I know that you guys have solved these before. So it should be pretty simple. So let's look at it. So example number 8. Calculate the number of milliliters of concentrated hydrochloric acid, so 12.0 molar hydrochloric acid, that must be used to prepare 500 milliliters of 2.0 molar hydrochloric acid solution. So we are diluting fully concentrated hydrochloric acid solution to 2 molar hydrochloric acid solution. Hydrochloric acid is a very strong acid. For safety purposes, we don't need that strong of an acid, like if we're working in it in a lab. We're going to have a very heavily diluted just because it's a safety hazard for us. So let's look at that conversion. So we're going to set it up typically like in the order that it gives you, really. So we're looking for the number of milliliters that we're going to need of this 12.0 molar. So we're starting with M1, is this 12.0 molar. And then we're looking for that volume in milliliters. Then our final molarity that we want is 2.0 molar. And then our final volume that we want is 500 milliliters. So that decimal present is important. That means we have 3 sig figs. So 3 sig figs in all of our answers. So we're going to multiply 2 by 500, and then we're going to divide by 12. And that is going to give us 83.3 milliliters with 3 sig figs. We don't need to convert milliliters to liters and then back to milliliters. As long as our units match, so milliliters here and then milliliters is what we're looking for, then we'll be fine. But if our units didn't match, then we would have to convert probably to liters. Okay, so let's look at number 9. If 42.9 milliliters of 3.02 molar sulfuric acid solution is diluted to a final volume of 500 milliliters, what is the molarity of the diluted solution of sulfuric acid? So we have our initial volume, initial molarity, and then our final volume is this 500 milliliters, and we're looking for M2 basically. So we're going to plug into our equation. So initial molarity times our initial volume is equal to the molarity, final molarity that we're looking for, times our final volume. So we're going to multiply these two numbers and divide by 500. And with 3 sig figs, we get 0.259 molar sulfuric acid as our diluted molarity. So now you can do the molarity and dilutions worksheet.